If V equals 12 volts, shown in the circuit below, what will be the current flowing through the main branch? In other words, what's the total current if we have a voltage of 12? So we can put our battery, which we're trying to find the voltage of, right there at the beginning. And this is what we're trying to figure out for its current draw. So the voltage is 12 volts. I want to know how much current is coming straight out of the battery. What is I? Now we've got a combination circuit here. There's some series, there's some parallel sections, and we just have to organize it. But let's start with the general idea. We want to use Ohm's law, which says V is equal to I times R. Now we know the total voltage. We're trying to find the total current. So we have to put total values in our formula. So V0 is total voltage, I0 is total current. In order to find total current, I need total resistance. So we have VO, we're trying to find I0. We need to figure out what R equivalent is, what my total resistance is. So now we got to break the circuit down. Well, if you look at here, I've got my current flowing out of the battery. It flows through the 1 ohm resistor and reaches this junction. And the current can then choose to go through the 4 ohm where the junction closes and it continues again. Or it can go through this outer path, which consists of a 2, a 3.9, and an 8. So we've got a parallel section there. As soon as the current splits up, we've got two things that are in parallel. Now I like to start, if I can, as far away from the battery as possible. So I'm going to look at this last little section in here. So what have I got? I've got a 4 ohm in parallel with a 2, 3.9, and an 8, which are all in series. Now we know those are all in series because there's only one path that the current can flow through that outside section. So those three are said to be in series. So let's do the outer series section and figure out what the equivalent resistance is of just that one little path. And I'll call that R series. Now in series, we add them up. R1 plus R2 plus R3, however many there are in series. In this case, there's only the 3. Doesn't matter which is which. So we just add them up. 2 plus 3.9 plus 8. And that'll give me ohms. So we end up getting our series section is 13.9 ohms. So now I can redraw my circuit. Now you don't have to do this step once you get good at it, but let's just, for starters, make sure we're all organized. So I've still got my 1 ohm. My 4 ohm still exists, hasn't gone anywhere. And there's still a 7 ohm down below. And I've still got this junction. The only thing I've done differently is I've replaced all 3 of those outer resistors with a single resistor that's 13.9 ohms. So I've got a single resistance in there. I'll put it in pink. It's equivalent to 13.9 ohms. Now again, I like to start as far away from the battery as possible, so I'll look at those two. The 4 and the 13.9 are in parallel. And we know our formula for parallel. 1 over R parallel is 1 over R1 plus 1 over R2. So that's going to be 1 over 4 plus 1 over 13.9, which, if you've been following the previous videos, I write as 4 to the minus 1 plus 13.9 to the minus 1, and use that x to the minus 1 button on my calculator. Now don't forget, once you hit equals, when you've done this little combination here, the 4 to the minus 1 plus 13.9 to the minus 1, you have to flip it one last time. And you'll end up getting the parallel section equivalent to, so if I go 4 to the minus 1 plus 13.9 to the minus 1 equals, and then flip it, I get 3.1 ohms. So the parallel becomes why don't we give it 2 decimals, 11 ohms. Now again, I like to just make sure that makes sense. It's always got to be smaller than my smallest parallel resistor, which is a 4. We're good to go. So we could draw it one more time. I get 1 ohm, and my 7 is still there. And I've replaced the 4 and the 13.9 with a single resistance that's now 3.11. And we see there a simple series circuit. So my equivalent, my total resistance, will be 1 plus 7 plus 3.11 ohms. So that becomes 11.11 is my overall resistance. And now I can finish the question. I'll do it in blue. Remember, I'm trying to find my overall current. So I'm using Ohm's law. So I0 will be V0 divided by R0, total values. Total voltage is 12. My total combined resistance was 11.11. And when I do that, I get 1.1 amps.